My next topic is to find the equations from the graphs of a piecewise function. Remember, in the previous examples, equations were given. We were driving the graph from that equation. But here it is the other way around. The graphs of the piecewise functions have been given. We're gonna derive the equation from the graph. Last time we were driving the graph from the equation. Right over here, we're gonna derive the equation from the graphs. Like in XY plane, this is my first piece of the graph, which is a parabola. Here is another piece of the graph. In here is a third piece of the graph. The graph of this piecewise function has 3 pieces. I'm gonna derive the equation for each and every single piece. Equation will be y equals to f of x. Whether you write y or f of x, this is exactly one thing. For the first piece, it's a perfect parabola. So I have no issue at all. I'm gonna simply put x squared with the border values -3 and +3. Why I directly put x squared here? Let me explain it a bit about the parabola. We're gonna study parabola in depth in upcoming lectures. If the vertex of the parabola, this is the vertex of the parabola. If the vertex of the parabola is located on the origin, then this whole graph is simply equals to x squared. You can directly put x squared because the vertex of the parabola is located on the origin with the border values -3 and +3. The coordinate points of these ends are 3, 6. This point is located on -3, 6. This 3 is a +3 along x-axis. 1, 2, 3. And 6 along y-axis. 1, 2, 3, 4, 5, 6. Similarly here, -3 along y-axis, -1, -2, -3. And +6 along y-axis. 1, 2, 3, 4, 5, 6. These are the coordinate points along x-axis and y-axis. The condition says that x must be equal to and greater than -3. Equal to -3. This is my -3. Equal to, that is equality bar, therefore I have filled in circle. But then greater than -3. So greater than -3 means we're gonna go in the right direction. We cannot go in left direction because they are lesser than -3. But then x should not cross 3, should be less than +3. We start from here from -3 and we are going in the right direction up to +3. This is my second border value. I cannot cross this +3. Remember, there is no equality bar here, there is no equality sign. So I simply put an empty circle for this end, which means that +3 is not included, but -3 is included because of this field in circle. My mission is within this region, within -3 and +3. I cannot go beyond this, I cannot cross this limit. So there was my first equation from this piece of the graph. That was simple. But for the other pieces of the graph, we're gonna go through the process to find the equation for these straight lines. So we're gonna apply the equation of the line. Let me take the second piece of the graph. It's -3 along axis, -1, -2, -3, and -4 along y-axis, -1, -2, -3, -4 along y-axis. These are the coordinate points for this stage. The other end is -4 along y-axis, -1, -2, -3, -4 along y-axis, but -infinity along x-axis. Remember, this graph is going in x direction, not in y direction. So in x direction, it goes in infinity, in -infinity. This arrowhead means it goes in infinity, but in -infinity. So these are the coordinate points. Since it is a straight line, so we're going to apply the equation of the line y minus y sub 1 equals to m of x minus x sub 1, where m is the slope of the line, which is y sub 2 minus y sub 1 or x sub 2 minus x sub 1. Substitute the values for the x and y here. This -4 is my sub 2. This one is my sub 1. -infinity is my x sub 2. -3 is my x sub 1. Do simplification, you will get 0 at the end. So my slope is 0 here. What I did here, the same is my slope of the line, which equals to y sub 2 minus y sub 1 or x sub 2 minus x sub 1. I just substituted the values. Y sub 2 is my -4. y sub 1 is my negative 4 here, x sub 2 is my negative infinity, x sub 1 is my negative 3. So after simplification I got 0 at the end. So my y minus y sub 1, I just substituted negative 4 for y sub 1. This is my negative 4, which is y sub 1. And negative 3 for x sub 1. This is my x sub 1. I just substituted negative 3 for x sub 1. 0 for the slope of the line, which is here. My m is 0 here. Let me simplify the equation. I will get y plus 4 equals to 0. This implies that y equals to negative 4. Negative 4 is my required equation. I just derived the second piece of equation for the second graph with the border values negative 3 less than negative 3. This is my second derived equation for the second piece of graph with the location along x-axis, which says that x must be less than negative 3. It goes in infinity in negative direction. This end has an empty circle. Because of this condition, let me explain it a bit. After simplification I got y equals to negative 4. This negative 4 is my second equation for the second piece of the graph, which is here. I just derived this equation from the number line with the condition which says that x must be less than negative 3. But when you look to the graph, without this process, you can simply put negative 4 with this limit because it is pretty clear from here. Remember, this graph starts from negative 3 along x-axis and negative 4 along y-axis. And then it goes in infinity, in negative infinity in left direction. So I have only one border value, which is here. I don't have any other value. The other end of the graph goes in infinity. There is no specific end for this graph. It goes in infinity. Therefore, I'm going to apply this condition, x less than negative 3. Less than negative 3 means that I will start from negative 3 and it will go lesser than negative 3 in negative infinity. Since there is no equality bar, therefore I have an empty circle for this end, which means that negative 3 is not included. Where I got this negative 4, it is along y-axis, negative 1, negative 2, negative 3, negative 4. This is my negative 4. This whole graph is my negative 4. Because remember, as I said, that this whole region belongs to the y-axis. Whatever we do here, it belongs to the y-axis. This negative 4 means we're gonna count negative 4 below the x-axis. But it is better to go through the process by applying the number line. It is an accurate process to derive the equation from a straight line graph like this. Let me derive the third equation from the third piece of the graph, which is this one. Their coordinate points are 8, 0 and 3, negative 4. It is an 8 along x-axis. 1, 2, 3, 4, 5, 6, 7, 8. But 0 along y-axis. This point is 0 along y-axis. 3 along x-axis. 1, 2, 3. 3 along x-axis and negative 4 along y-axis. Negative 1, negative 2, negative 3, negative 4, negative 4 along y-axis. These are the coordinate points along x-axis and y-axis for this piece of the graph. Again, from the line equation, y minus y sub 1 equals to m of x minus x sub 1. M is the slope of the line, which equals to y sub 2 minus y sub 1 or x sub 2 minus x sub 1. Substitute the values here. Negative 4 is my y sub 2. 0 is y sub 1. 3 is x sub 2. 8 is x sub 1. Simplify it, I'm gonna get 4 over 5. 4 over 5 is my slope of the line. Substitute it for m here. I just substituted 4 over 5 for the m, which is slope of the line. 0 for y sub 1. My y sub 1 is 0 here. And x sub 1 is 8. This 8 is my x sub 1. After simplification I got y equals to 0.8 times x minus 6.4. This is my third equation for the third piece of the graph. 0.8 times x minus 6.4 with the border values 3 and 8. Both the ends have filled in circles. The 0.8 times x minus 6.4 is my equation for this straight line with the border values 3 and 8. The condition says that x equal to and greater than 3. Equal to 3, 1, 2, 3. But then greater than 3. Greater than 3 means that I will go in right direction, in positive direction. Up to 8. Equal to 8 but less than 8. Equal to 8 and less than 8. So one border value is my 3 and the second value is 8. I start from 3 here and then end it at 8. I cannot go beyond 3 and 8. These are the border values. So within this region, I have my graph. That's how I derived this equation from the number line with the location along x-axis. Since both the ends have filled in circles, so I'm gonna put equal to for the 3 and equal to for the 8. The sub-bar means equal to 3 and equal to 8, which means that 3 and 8 are included. That's how I derived these three equations from these three pieces of the graph. For the first one is x squared, which is a parabola. For the second one is -4. For the third one is 0.8 times x minus 6.4. This border value is not an issue as long as you have the x coordinates and y coordinates points. You can easily identify these conditions along x-axis. So that's how you have to derive the equations for the piecewise function if different pieces of the graph have been given. Like I did here. For this piece I got parabola. For the second piece I got -4. For the third piece I got this equation.